Hello, in this video we will learn about finding reacting masses. We know for most of the chemistry learners, we always find that the stoichiometry, even as complicated as the name of that sound is, the calculations, the idea about concept of mole is always very challenging, and then it can be one of the stumbling blocks that killed off a lot of interest in chemistry learning. However, we're able to discover another choice or approach of calculating reactive masses of a certain reaction without using mole. Okay, so I've shown that in this video we are going to calculate reactive masses instead of using mole, which is something that could be challenging, but we're going to use some very simple mathematical skill, and which we can call it unitary method, or the second one is direct proportional method. Well, for both of them, again, it may sound complicated for those who are not familiar with maths, but the item number one, the method number one, is just as common as we use it whenever we do any purchasing, any shopping. So for example, when we buy 5 pieces of orange and it costs us $20, and how much one piece of orange costs. Yes, that is the simple idea about method 1, unitary, meaning finding one unit, how much does it bring along. And the second method is just using a simple direct proportional. That means we compare the ratio of 2 items in their direct proportional. Alright, so we will move on and to give more understanding using examples not involving chemistry. Here we go. We are going to get familiar with these 2 mathematics skills without using chemistry examples. Okay, I put out here example 1. No scary chemistry terms at all. Alright, we were using the questions I put there. 12 grams of sugar is used to make 5 puddings. Yummy, right? How many grams of sugar is needed to make 8 puddings? Okay, in using this simple method, I'm going to demonstrate for all of us both of the methods, and both of them will come to the same answers. And for you, you can comfortably choose which is the one that works best for you. No pressure, and then just take your time to observe and then choose which one you are comfortable and comfortable with. Alright, so now, and it was given us the ratio of sugar and puddings, right? So 12 grams of sugars will produce 5 puddings. So now the questions now is the numbers of grams of sugar to make 8 puddings. So now we wanted to find first we want to find 1 grams of sugar, okay? No, 1 pudding, alright? In order to make 1 pudding, how much sugar do you need? Alright, so you just use some very common idea. So 1 pudding require how many? So we're going to take 12 divided by 5 puddings, right? So as straightforward as it is. Now you move on. You now wanted to make 8 puddings, so you just, so 8 puddings require how much? So you just take whatever this amount of sugar, alright? So you just put in there, and then now you are going to multiply this by 8, okay? And let's take a look at that. So 8 times 12 divided by 5, you are going to make 8 puddings. Your calculator will show you you're going to use 19.2 gram of sugar. Okay, so this is using unitary method. The direct proportional method is just simply put in, you are talking about sugar, so you just put down there, you are interested in sugar, and what is their ratio to pudding. Okay, let's put out there pudding. Alright, so just the idea of sugar and pudding. So now just simply take from the question 12 grams, so you can just simply put there. If you do not want to put that colon sign, if you that kind of like forming kind of like mathematical pressure on you, no, you don't have to put it. Kind of like just simple relating like that. Okay, 12 grams of sugars will make 5 puddings. Now you want to make 8 puddings. So how many sugar? Just simply put an X, an unknown. Okay, any symbol you like. Okay, so now once you get in there, so you just take. You want to find X, so just simply put the X at the top, and the 12 just put it at the bottom. And also in the same way, since X is at the top, therefore the 8 will also be at the top, so you just put 8 over 5. Okay, then by simple just multiply the 12 over. Okay, so you're going to get 8 over 5 multiply 12, and you can easily get the same answer. There you go. So this is the using the simple mathematical calculation. Now we go to example 2. Okay, using the same idea, 12 grams of sugar is used to make 5 puddings, same idea, but this time we want to calculate how many puddings, okay, can be made using 108 grams of sugars. Well, again, for unitary method, it's always find 1 unit. So let's put in 1 unit. This time 1 unit of what? 1 unit of sugar can produce how many puddings? Okay, so how many puddings? Okay, so now what we're going to do, so we're going to, because we want 1 unit, so we're going to divide by the sugars. Okay, so 12, and then so 5 divided by 12, and therefore now you want to use 108 grams of sugar. And simply, okay, so now how many puddings can be made? Okay, so just simply put in 108 grams multiply this 1 unit sugar. Okay, so you just take this and just paste it there, and hopefully you find how comfortable that is. Then go to the calculator, 108 times 5 divide 12, and you tada, you got for yourself, yes, 108 grams of sugars can make 45 puddings. Okay, then if you want to use the direct proportional method, in the same way as we are interested to compare sugar and pudding. Right, so now what's given to us 12 grams will make 5 puddings. Alright, now how many puddings? So how many, we just put an X, an unknown. You want to put M, you want to put P, whatever alphabet letter, or if you want to make a flowers, it's up to you. Okay, it's just put an unknown. Okay, so I will just put an X, which is easier to, so much better than just draw a flower, right? So so now how many pudding can be made when we put 108 grams? Now guess what? What do you, okay, how do you arrange that ratio? Okay, so you know that you're going to have something in an equal, and you're going to put in the ratio, right? So the one we're interested to find, let's prioritize them and put in that X. So X over 5, that will give you 108 over 12. 108 over 12. It's practical, like not with doing maths. It's just kind of arranging, decoration in your room, right? Just nothing complicated, but it's more like arranging. Now you just going to divide 5, you were just going to times 5 over, right? So 108 over 12 times 5, and get the calculator, and again it will tells you 45 puddings. Okay, so this is the non-chemistry examples. Okay, so we have given 2, and I think you're quite comfortable with this now. Let us step into chemistry world. Okay, now I put in the first example here. A student obtained 48 grams of magnesium from magnesium sulfate, 48 grams of magnesium sulfate from 9.6 grams of magnesium. Okay, so what mass of magnesium sulfate can the student get from 1.2 gram of magnesium? Okay, so you are now using 1.2 gram of magnesium. So you want to say, okay, then how much magnesium sulfate can we get? Okay, so let's demonstrate with the unitary method. Again, we want to find 1 unit. 1 unit of what? Now you want to check magnesium. So let's check 1 unit of magnesium. Okay, 1 unit of magnesium. Okay, I'm going to save time by writing some symbol. So I'm going to put down the symbol for magnesium sulfate. Okay, the symbol for magnesium sulfate is MgSO4. Okay, and then of course the symbol for magnesium is Mg. All right, just to make sure we communicated well and with the chemical symbol. So now 1 gram of magnesium can produce how much of magnesium sulfate? Okay, so what you do, you just divide how much magnesium. So let's put in the magnesium used here is 9.6 gram. Okay, and then this is 9.6 gram of magnesium. Now they produce 48 gram. Awesome, right? So now this 1 unit of magnesium produced this much of magnesium sulfate. Therefore, now you are going to use 1.2 grams. So you just take that 1.2 gram of magnesium. How much would you produce? Just put 1.2 here and multiply this ratio that you have just from that 1 unit. Okay, of course now the gram will be no need to be there, so you can just put in. All right, so 1.2 is 48, then divide 9.6, that gives you 6 gram of magnesium sulfate. There you go. Okay, so this is unitary method. Now let's go to the direct proportional method. Okay, it will get the same 6 gram. Okay, let's do this. All right, so we get so magnesium. So now we are interested magnesium and magnesium sulfate. So I'll just nicely write there, and then 48 gram of magnesium sulfate. So we just put 48 gram under the title of magnesium sulfate, and from what? Magnesium 9.6. So 9.6 is magnesium, so we just put in that. Okay, so you see, you just arrange the word from English back to that simple comparison table. Then now you say what mass of magnesium sulfate? What mass? That means the unknown is here. Just simply put this is unknown. Okay, or even if you want to, just put a question mark, up to you. Okay, as long as you understand that is what you are looking. However, I'm going to use X, and then can the student get from 1.2 gram? 1.2 gram of what? Of magnesium. Okay, so just put that. So now we just going to arrange the equation. All right, so the X you are looking for, X over 48, that will equivalent ratio to 1.2 divide 9.6, and with one simple flip of that, multiply 48 you can just press the calculator and I bet you will get this beautiful number 6 there. Got it? Okay? Alright, so why not we move on to one more example. Okay, one more example and you'll be ready to give it a try. Okay, let's read the questions together. If 0.24 gram of magnesium react with 0.16 gram of oxygen to produce 0.40 gram of magnesium oxide, how much magnesium oxide MgO will be produced by burning 12 grams of magnesium? Okay, so now, most important, just as we did previously, just identify who are the two chemical or who are the players that we are interested to look at now. Okay, so the question seems to mention magnesium, oxygen, or magnesium oxide. This seems to have 3 persons, but what you are interested is only, let's underline, what are you interested? Okay, you are interested on, they ask how much magnesium oxide, okay, that is the unknown you are looking for, magnesium oxide, will be produced by burning 12 grams of magnesium. These are the 2 players you're interested. That means oxygen, you're not interested, so just leave it. Alright, you will focus on only magnesium and magnesium oxide. Okay, so once you got this, so now let's find out if you are interested for unitary method. They are asking 12 grams of magnesium to produce how much of that? So that means you want to take 12 multiply 1 unit of magnesium, correct? To produce how much of magnesium sulfate? So let's go on to 1 unit of magnesium, okay, would produce how much of magnesium oxide? Okay, magnesium oxide. Alright, so just to so therefore you get from here, they say 0.24 gram produce this much. Okay, so that means I'm going to divide by the magnesium, 0.2, writing 0.24, okay, gram of magnesium producing how much was it? 0.40 gram. So, okay, so you're going to find 0.24 is magnesium. So you just 1 unit of magnesium. So you divide by magnesium. Okay, just like in a simple daily life, if 5 oranges cost $20, so 1 orange costs how much? You just take the 20 divided by orange. That means divided by 5 oranges, that you get 1 unit. Okay, so using that simple mathematical concept, now we move on. Okay, now 12 gram. Alright, so we're going to take, alright, 12 gram of magnesium now. How much would you produce? You just take 12 times this fella. Okay, 0.40 divide 0.24. And nicely 12 multiply 0.4 and then divide 0.24 and you will get 20 gram of magnesium oxide. Okay, and that is unitary method. Now let's go to demonstrate for you direct proportional method. Again, you just list down the 2 players or 2 chemicals that you are interested to find. Okay, we are interested to find magnesium, so I'm just going to magnesium. The other player we are interested is magnesium oxide. Just put down there magnesium oxide. Well, if you can't write the chemical formula, no worry, we just put in English word, okay? And we try to make more videos and explain how to write chemical formula. Okay, now let's go in. Just arrange this, okay? 0.24 for magnesium, you just put it down here, okay? 0.24 is magnesium And then this amount of magnesium produce how much of magnesium oxide? 0.40 gram. Take that, put in its relevant place. Okay, so this many produce that many of magnesium oxide. Okay, now they asked you how much magnesium oxide. That means the mystery mass will be there. Magnesium oxide, which is the question that you try to find out, is produced when 12 gram of magnesium is here. Again, start decorating, start arranging. Okay, just like flower arranging, have fun with that. 0.40 and then arranging 0.24. I don't feel I'm doing maths, I feel more like flower arrangement. Okay, all right, and then so 12, 0.24 multiply that 0.40. Then you can just press a calculator, you will come up with 20 gram of magnesium. What is this? Yeah, magnesium oxide. See, same answer each time. Okay, so take your time to choose which is the method you prefer. Okay, nothing pressurizing about that. Just choose the method that you are comfortable. All right, so now let's move on to one more. Okay, at times they may give chemical reaction like this. Okay, because I find it taking time to press to key in the chemical equation with the subscript. So to me, I just handwritten. Pardon me for my handwriting. Yeah. Okay, let's read on. In the reaction of magnesium reacting to copper sulfate, okay, producing magnesium sulfate and copper. Now, they give to us 6.4 gram of copper are formed. So this is 6.4 gram of copper is formed from 2.4 gram of magnesium. See the ratio? You can see the comparison, the two players. So you are interested in magnesium and copper. Okay. Then the other two, these two, it is not your concern in this question. All right. So now, what mass of magnesium is needed to get 32 gram of copper? Okay. Now you want to get 32 gram of copper. So now let's demonstrate with unitary method. Okay. In order to get, now you got 32 gram of copper. So let's find out 1 unit copper require how many gram of magnesium. Okay, so therefore we want to find out how much magnesium. Guess what? You may pause the video and try to put in. Who would you put in as denominator? You want copper? And join me later when you have thought about this. I believe you have thought about this, and let's move on. So if you want the 1 unit copper, you just put in copper, 6.4 gram of copper down here, producing 6.4 gram of copper are formed from 2.4. So magnesium, I'm just going to put there 2.4 gram. Okay, so now one unit of copper, 1 gram of copper, producing this much of magnesium. So now you want to collect 32 gram of copper. Therefore, you take 32 multiply 2.4 divide 6.4, and let's say 32 times 2.4 divide 6.4. My calculator will tell me 12 gram of magnesium. Okay, this is unitary method. Let's hop on to the direct proportional method. Again, it's just like decoration again. All right, so you are interested between magnesium, so I will just put in magnesium, copper. How you arrange does not matter. Okay, please rest assured, if you want to put copper here, magnesium here, does not matter. All right, it's just like, okay, you put your flowers here, you put a picture there, or you put a picture there and flower there, it does not matter as long as you put them in the right place. Okay, so now you are looking for how much magnesium? Magnesium 2.4, you just put under magnesium. Got it? Okay, so let's put in 2.4 gram of magnesium will relates to how much? Well, this 2.4 gram of magnesium will produce how much? 6.4 charge. So this will give 6.4 gram. So let's put there 6.4 gram. Okay. Does it smell mathematics at all? No, right? Okay, this is the beauty of happy learning. All right, let's move on. Okay, what they ask us to find is what mass of magnesium is needed. Okay, now what mass of magnesium is needed? Okay, and to produce is needed to get 32 gram of copper. In the same way, let's arrange that. Okay, doesn't look nice with different color, just put in. Okay, so now you can pause the video and try to arrange that and join me later. Okay, I trust you already give a thought to it. Let's go. So I want to make things easy. The item I want to find, I will put at the numerator. Then I'm going to put 2.4 down here, and then since x is up, 32 will also be up. Oh, not 32. Now the 6.4 will be down there. Okay, just flip that over. Okay, 32, 6.4, just multiply that 2.4 over, and you will get the same 12 gram of magnesium. See that? Okay, so you find that the calculation on both sides is actually so see 32 times 24, 32 times 24, and divided by what? 6.4, same. The only thing different is the way they approach the calculations. Alright, so now we have done some examples, and then this is the questions the students snapshot and sent to me. Pardon me for using this the copy that the students snapped to me. I tried to find the original, the clean and nice copy I couldn't find. So let's learn to this. Okay, the clarity is quite good. I believe you can do something with this. Okay, now this is the real past questions. Then a student investigate the reaction of a small piece of calcium carbonate with dilute hydrochloric acid. The hydrochloric acid is in excess. Okay, now of course we shall keep more explanation for all these in the other time. Now we want to focus only on reacting mass. Okay, so let's focus what is interested to us. Okay, 0.11 gram of calcium carbonate, right, is used to produce 25 cm cube of carbon dioxide. Okay, gas is produced. Calculate the mass of calcium carbonate needed to produce 100 gram of carbon dioxide. Okay, if I just want to make things easier, I can just kind of like translate that onto here. Okay, this is calcium carbonate, and then this calcium carbonate, so I can just put down here 0.11 gram there. Okay, it's used to produce what? 25 cm cube of carbon dioxide. 25 cm cube. Got it? See, I just kind of just put it there instead of me writing the title like that. Okay, so I just put in there, and then now let's look out for what do they ask. Calculate the mass of calcium carbonate. That means this is the questions. All right, okay, so this, how much that is, how many gram that is, you can put question mark again, choose whatever alphabet letters or things that, as long as you know that is the things you're looking for, how many gram, okay, of calcium carbonate needed to produce, you want 100 cm cube. Okay, so now if you want to use carbon dioxide, to produce 100 cm cube, okay, again down here I'm going to demonstrate both method, and you take your time to choose which is the one. Okay, so for the unitary method, okay, since the point of reference is carbon dioxide, okay, where I know I'm going to take 100 multiply something, okay, 100 some of the carbon dioxide. So I will just take 1 unit of carbon dioxide. So 1 unit carbon dioxide, okay, is produced from how many of calcium carbonate, all right, using. So again, let me pause here and you give a thinker, who will you put in as a denominator? Who will you divide with? All right, so I'm sure you have made up some thoughts to it and you have got your conclusion. You divide by 25, right? Because you are referring how much 100 grams, so you're going to divide by carbon dioxide, and then how many gram do you use? 0.11 gram. Okay, so then this much of carbon dioxide. So now there you go, you're going to, in order to collect 100 cm³ of carbon dioxide, you're just going to put in that 100, okay, you want 100, so multiply 0.11 divide 25, okay, so you just multiply that. 100 divided 25 will be 4 times 0.11, that gives you 0.44 gram of how much? Of what? Calcium carbonate. Okay, now that is unitary method. Let's hop on to the direct proportional method. Okay, so just going to put here the calcium carbonate produce the CO2, right? So just list down how much is the calcium carbonate. 0.11 gram, producing how much? 25 cm³ of carbon dioxide. Now they say how many gram of the calcium carbonate, so just put an X or question mark, whatever you like, and then to produce 100 cm³ of carbon dioxide. Start arranging. So just put in X divided by 0.11 and put up here 100 divided by 25, and here X, just flip that, multiply that across times 0.11, and again, so you're going to get 0.44 gram of calcium carbonate. So the answer, okay, here will be 0.44 gram. Okay, there you go. So that's done. Okay, and so that is how easy we can work on reacting masses, even we haven't yet mastered or understand the concept of mole. However, it is still necessary to learn and master the concept of mole, but that will be for other time. Okay, so we have come to the end of this video, and I hope you benefit from this and just go on and enjoy your chemistry learning, and just discover learning was always happy and not supposed to be hard. Alright, so keep in touch. I'll see you in the next video. Alright, bye bye.